So let's begin. This talk is how to learn Elixir security. Thank you for that really fantastic introduction. So Praxeal.io, as a company, it's an Elixir security platform, but there's also professional services such as Elixir developer security training and penetration testing and consulting. So that's an overview of the company. This was already covered, so I won't dwell on it, but essentially Praxeal.io was started because there's a lot of companies using Elixir, but none of the big security vendors really support Elixir. It doesn't get much attention yet. So that's a big motivation with the company. And I want to start my talk today with a narrative. So this is from a security textbook that I have, and we're talking about a bank with a web application. So I'm going to read from my slides. The authentication mechanism had been subject to numerous design reviews and penetration tests. The owners were confident that no feasible means existed of attacking the mechanism to gain unauthorized access. In fact, the authentication mechanism contained a subtle flaw. Occasionally, when a customer logged in, he gained access to the account of a completely different user, enabling him to view all that user's financial details and even make payments from the other user's account. The application's behavior initially appeared to be random. The user had not performed any unusual action to gain unauthorized access, and the anomaly did not recur on subsequent logins. After some investigation, the bank discovered that the error was occurring when two different users logged in to the application at precisely the same moment. It did not occur on every such occasion, only a subset of them. The root cause was that the application was briefly storing a key identifier about each newly authenticated user within a static non-session variable. After being written, this variable's value was read back an instant later. If a different thread processing another login had written to the variable during this instant, the earlier user would land an authenticated session belonging to the subsequent user. So, this is a very long description, but at a high level, you're an executive at a bank and people are getting logged into the wrong bank accounts, which is horrible for security. And then from a technical perspective, people on this call probably get where I'm going with this. The root cause of this is that this web application, which was probably written in C or maybe Perl when this book first came out, but it could have been Python, Ruby, JavaScript. None of these languages have a really strong guarantee against this type of vulnerability, which is called a data race. If you've used other languages with mutexes or locks, where you have to lock certain variables from being modified, it's because of this thread unsafe code. So in Elixir, you don't have this problem at all because each process in the beam runs in an isolated memory space. And I want to clarify here, race conditions are a different thing from data races. So you could have something in ETS, for example, where you have multiple processes acting at the same time. That's a race condition. But what specifically happened in that narrative at the start was a data race, which is impossible in Elixir. So I published an article on this on the Praxeal.io blog. It's the one with the track. The reason I start this talk with this story is that when companies consider adopting Elixir, security is a very big topic that gets discussed. And the larger the company, the more they have to lose, the more they probably care about security. So, banking and healthcare. Consider the executive at a bank. You go to them, they don't know anything about Beam, functional programming, mutability, these things that we concern ourselves with. You could really sell this as, hey, we're using Python, but then there's this problem where people get logged into the wrong bank account, and that's a massive security problem. There's this new language called Elixir. It doesn't have that problem at all. If the executive gets it, they could say, sounds great, let's use Elixir. And now there's 100 new Elixir jobs on the market that are very well paying. It would be huge for adoption, but this fact doesn't really come up in adoption conversations from what I've seen. And I wish people would talk about it more. So my argument that I'm going to present to start this talk is that Elixir is more secure than other languages. NPM with JavaScript is pretty much a mess right now. Every day it's in the news for malware or people updating their package. There's this problem with typo squatting, and you just don't see it with Hex at all. Hex is very well designed and they're very on top of those things. The data races is the example I gave to start this. And then finally, with PHP, I don't know if people on this call have done PHP much. There's literally functions in the standard library where they say, don't use this because it's not secure. And Elixir kind of has the opposite problem, or not problem, but with Ecto, for example, it's very difficult to introduce a SQL injection vulnerability as an example, because Ecto is really well designed and encourages you to write secure code. So having a positive narrative for Elixir's security benefits will increase adoption. So take a step back. Let's think about data breaches or hacks, like big hacks of companies when you hear about them in the news. So this is just Acme Corp. You can see that we've got users on laptops. There's some internal servers, and then there's some servers that are sort of facing the web and the public internet. On the public internet, we've got bad actors, bots, spam, hackers. There's also the kind of cloud hosted services, Gmail, iCloud, YouTube. So if you're working at a company, you probably have a laptop where you connect to Gmail, and this part of it, we're going to call it desktop client software, where you're on a Windows laptop or a Mac OS, you've got a web browser, and an email comes in and ransomware infects the company that way. That's a very important part of InfoSec, but it's not going to be related to what we're talking about. That's a sort of a separate thing. What we're interested in is application security today, which is specifically software that this company is running. It's very important to the business, and it's facing this malicious public internet. Okay, so now we've got the bad actors. They're communicating with the web servers over, HTTP, SSH, FTP, whatever protocols. And those web servers, think of them as a food item in your refrigerator. What would be on the label for a thing of oatmeal, for example, if it was a web server? It's a great analogy. You'd probably have Linux, OpenSSL is probably running in there, Nginx, Dockyard, it's probably on AWS. You probably do not write this code at your job. So this is often called the infrastructure in a network. Your code runs on top of it. The security of all of these, software is very important, but, hundreds of people just do Linux security for their career. You're kind of building on top of it. What we're talking about here is specifically Elixir and Erlang security. So you're probably using Cowboy if you're running Elixir in production. So an HTTP request comes in, it goes to the web server, which is running Cowboy, and then your application code is in Elixir. So data from the public internet should be treated as malicious, meaning it's not guaranteed to be well-formed or even something you could trust. Any software that's on the public internet gets attacked constantly. You can't stop it. So anything that's publicly facing, it has to be protected against these kind of attacks. But you might ask, what's the impact if it is vulnerable? This was a really high profile example here in the United States. Equifax suffered a data breach. It was due to their public facing web applications, and the cost to their business, just monetary, was over $400 million. Their reputation is now, the data breach company. It's sort of a cliche even to bring them up when you're doing an InfoSec talk. The United States Senate did a report on what happened at Equifax, and Apache Struts shows up hundreds of times in the report because that's how the attackers got in. What's Apache Struts? It's to Java what Phoenix is to Elixir. From their website, it's a free open source MVC framework for creating elegant, modern Java web applications. So you can see Apache Struts was this very important part of this data breach incident. So now executives ask questions about, oh, we're not using Java. Java has struts. There's this new thing, Elixir. Is Phoenix secure? So your Elixir code is probably exposed to the public internet. And now you might see why business people are very interested in the security of this code. So imagine an executive comes up to you and asks, hey, how are we securing our Elixir code? I heard about this Equifax thing. It was very bad. And you can't really shrug your shoulders. That's the wrong thing to do. Any business needs an answer to this question. And if you're championing Elixir adoption at a company, you really need a good answer to this question. So for the topic today, I'm just going to focus on asset management briefly and then developer training, which I think is most relevant to this call probably. So for example, can you identify which versions of Elixir, Erlang, Phoenix, and Plug are currently running? Can you upgrade them in 24 hours? That process of being able to identify and patch things and upgrade them is very critical. At the same time though, as a developer, do you know what secure and insecure Elixir code looks like? Do you even know that you really need to be able to upgrade things quickly to avoid this Equifax problem? And do you understand why it's important from a business and technical perspective? Where do you even find material on this stuff? So there's obvious benefits as a developer learning about security. From a company point of view, there's the ethical and legal obligation, the fact that security incident I showed you is very expensive, but also when you budget for security, training developers is probably the best return on investment you can get. I run a company that sells a software security product, but I also get a lot of demand for developer security training because, having a staff that's knowledgeable is just so valuable. Then from a developer point of view, as a more senior engineer or as a lead engineer, you're really expected to know about security. It improves your skill set. You have a larger pool of potential jobs. You're a better candidate. And I personally think it's very interesting. So for getting started, this book, the Web Application Hacker's Handbook, the second edition, it's a little old now, but I still think it's the best introduction. That story I told at the beginning is from this book. And it sort of takes a generic approach where vulnerabilities like cross-site scripting, which is XSS, CSRF, SQL injection, RCE, these are sort of well-defined in InfoSec literature. And this book will allow you to familiarize yourself with what that means. However, there will be nothing in this book about Elixir specifically. So you can kind of see the gap where this book will tell you about web security and software security problems and kind of the history of them, but it won't be specific to Elixir and Phoenix. So I'm part of the Erlang Ecosystem Foundation, the security working group, and they published a secure coding and deployment hardening guidelines specifically for Elixir and Phoenix and Erlang. So this covers things like the atom exhaustion problem you might have heard about, why serializing and deserializing data is a security risk, protecting the sensitive data in your application. Feel free to start screenshotting too if you're watching, but if you're interested in specifically Elixir security, you should absolutely start with this document. The next thing I want to talk about is Soblo, which is the stack analysis tool for Elixir. It was written by Griffin, who actually gave an ElixirConf talk about security problems in Phoenix. So you should absolutely watch this talk. It's on YouTube. It's called Plugging the Security Holes in Your Phoenix Application. And you should be using Soblo if your Elixir code is facing the public internet. What you will quickly run into, though, is that Soblo assumes you know what cross-site request forgery, cross-site scripting is. The findings are not written in a way where if you're just a developer coming at this, that you'll understand the meaning, how to triage it, if it's a true or false positive, the severity of it, things like that. So as part of the Praxeal.io product, I have a basically inline guide for each finding on how to triage and fix it. But this guide is also open source, so anyone can just read it and use it. With Praxeal, the product offering is that you can buy engineering time to get help fixing these problems. That's obviously a commercial service, but you can see the benefit of just having this guide open source. Hopefully benefits the community. You can also read the source code of Soblo. It's a great way to learn about each vulnerability and see how the stack analysis is checking for it. But what you'll also run into is, okay, this is how it checks for it with, matching the AST and everything. But what if you want to see what vulnerable code looks like in a real Phoenix project? So this is the Potion Shop project. I'm one of the creators for it. It is a very basic Phoenix application that is intended to show what vulnerabilities look like. It's open source. I'll link it later in the presentation, but essentially it has all of these security problems like remote code execution, cross-site scripting, SQL injection, etc. You can run Soblo on this and see what these issues look like. So this is, feedback I've gotten about Potion Shop. It's that if you're learning how to use Soblo, it's hard to tell if the findings are true or false positive. You run it on a project, it tends to spit out a lot of issues. With Potion Shop, you can see what those true positives really look like, as well as learn about Elixir security, what the secure and not secure examples look like. So this is sort of an index of content on Elixir security, the EEF Security Working Group guidelines. Bram is the head of that working group. His blog is linked here. I highly recommend reading it. Griffin, the creator of Soblo, also has a blog that's linked there. The Praxio.io blog is where I publish content around Elixir and Phoenix security. Then there's also Potion Shop. That's on the Security Elixir GitHub organization. I've got a link to Soblo. And then I also want to mention this project that Holden, who's the current maintainer of Soblo, he was big in, was the Elixir Secure Coding Training live books, which are published by Podium. So this is pretty cool. It's live book examples of secure, insecure Elixir code, OWASP top 10 style problems. So this is kind of like an index of things to show, like, yes, people are interested in Elixir security. If we're considering adopting it, there's material and work being done in this area. Plug for myself, I'm giving a training on September 1st, fully remote at ElixirConf on Phoenix application security using Potion Shop. So if you're interested, the value's very good. It's much more affordable compared to a Black Hat training, for instance, which is about $4,000. It costs less than that for your training budget. And the last topic I want to talk about was runtime application self-protection for Elixir. This is a library that I released this week. It's part of Praxio.io as the commercial offering, but I also decided to open source it. So this name, the RASP, might seem kind of odd. This is an InfoSec term. So when a company is considering adopting Elixir in a high security context, it's literally a line item, like, do we have RASP for Elixir? And if you were to go to Elixir people, they might say, oh yeah, like the tracing's really good. You could code that yourself. Companies usually don't want that. They want to see, a library or a company doing it. So my hope is with Exploit Guard, that will improve Elixir's adoption in high security environments and give companies that are using Elixir a better story around the security efforts. So that's the conclusion of my talk. I'm very active on LinkedIn these days. That's probably the best place to contact me. You can also send me an email. If you book a meeting through Praxio, I'll get it. I'm pretty reachable, basically. But yeah, that's the conclusion of my talk. I will stop sharing, and I guess we'll go to QA now. But yeah, thank you, everyone.
Thank you very much, Michael. So I'll just turn on the Q&A. So if you have any question to Michael, you can just write it down on chat, and I will pin it to the screen. Maybe a question from me in the meantime. And when you just do the consulting, or you just implement your solutions to companies using Elixir, would you say that most of these apps are rather secure or not really?
Oh, the customers? Yeah, for sure. Like, they're already very secure. It's usually things like, I'll give the bot defense example, where when you have a login page, you want to be able to detect people doing a lot of login requests. That's not something that's built into Phoenix, and you can implement it yourself. It's just it's something that's very annoying to do. You really want to outsource it if you can. So reCAPTCHA is a common one, but everyone hates reCAPTCHA. So that's, a situation where you get a customer of Praxial. Another one would be compliance. So for example, you need to do SOBLO scanning, and then maybe you have that in your CI pipeline already. But then for compliance reasons, you need to produce a record that shows we did a SOBLO scan, every day for the past year. Praxial records that and gives business metrics around it. So definitely seeing demand in that way too. But yeah, in general, I would say that a Phoenix application is probably more secure than a PHP application.
Without any additional setup, like if you would basically create a scaffold of Phoenix application with an initial project, would you say that it's already more secure than what you get with other frameworks, or you don't have this kind of comparison?
For sure, yeah. And there's a number of reasons. The data race example, the fact that Elixir as a language is designed in a way that discourages you from introducing vulnerabilities. Hex just has less people that can do a change that, results in someone mining Bitcoin on your server. Everything is just better from a security perspective in Elixir. And I really want people to, mention that in adoption conversations and talk about that as a benefit.
Okay, thank you. We have a first question from the audience. So what's the most common security issue that you see in Phoenix apps?
It's a good question. I would say that probably the login problem is the most frequent. It's not really a traditional style vulnerability in the sense of SQL injection. Like I pretty much never see SQL injection as a problem because everyone uses Ecto. And if you're just doing that Ecto query default, you're fine. You'll never have a SQL injection problem. What usually does happen though is a website has a login page or something. Somebody writes a bot to do login attempts and brute forcing, and maybe there's a CAPTCHA or something, but people can bypass that, and then they just run 100,000 logins with stolen credentials and get access to people's accounts. That lack of rate limiting on the login, it seems like that's like a low severity finding. If you get a pen test done, some pen tests won't even report it because it's not high severity enough. But the lack of protection on the login page usually leads to like a major incident where someone's account got logged into, or credit card fraud, where people are creating accounts to try, hundreds of credit cards and see if they can make a purchase. It's a little counterintuitive because it's not like an OWASP, SQL injection. It's like a cool vulnerability, but that just lack of protection. Everyone that has a public facing web app hits that incident at one point for sure.
Okay, any other questions for Michael? All right. Okay, thank you very much then, Michael. It was a great presentation. I believe there is a huge interest in security in Elixir, and I would say that in most cases when I hear Elixir and security, I see you on the website.
Thank you.
So good work. Thank you. And I hope to see you yet another time as a speaker here. And of course, encourage everyone to also join the meetups that Michael organizes. Right, thanks.
Awesome. Thank you so much for having me. It was fantastic.